Sudoku. In this video, I combine pairs and x-wings to find possible numbers. Consider cell C2. There is no number 1. The number 2 already exists in the row. In the same row as cell C2, the numbers 3, 4, and 5 already exist. The number 6 already exists in the box. The number 7 has not appeared. In the same column, the numbers 8 and 9 already exist. Therefore, cell C2 can only contain either 1 or 7. I note the numbers 1 and 7 in cell C2. This will be used in the following steps. Continue with cell C5. There is no number 1 in the row, column, or box. In the same box, the numbers 2, 3, 4, and 5 already exist. The numbers 6 and 7 do not exist in the same row, column, or box. The numbers 8 and 9 already exist in the same column as cell C5. Therefore, cell C5 can only contain one of the three numbers, 1, 6, or 7. Note the numbers 1, 6, and 7 are in cell C5. Continuing to examine row E. In row E, the numbers 3, 4, 7, and 8 are already present. I am considering the possible positions of the number 6. The first cell in row E already contains the number 6 in the same column. Therefore, the first cell in row E cannot be the number 6. The last box on the right already contains the number 6, so the number 6 cannot be in cell E7 and not in cell E9. So, in row E, the number 6 can only be in one of two cells, E3 or E5. Continuing to examine row G. In row G, I am considering the possible cells for the number 6. The last box already contains the number 6, so cells G7 and G8 cannot be the number 6. The number 6 already exists in column 1, so cell G1 cannot be the number 6. Therefore, in row G, the number 6 can only be in cells G3 and G5. Results of examining rows E and G. The number 6 can only be in cells E3, E5, G3, or G5. The four cells E3, E5, G3, and G5 form an X. With this result, I assess how it affects cell C5. If E5 is the number 6, then C5 cannot be the number 6. If E5 is the number 6, then C5 cannot be the number 6. In another case, if E5 is not the number 6, then G5 is the number 6. When G5 is the number 6, then G5 is not the number 6 because they are in the same column. In both cases, if cell E5 is present, then cell C5 cannot be the number 6. Conclusion: C5 cannot be the number 6. Thus, cell C5 can only be the number 1 or the number 7. In row C, cell C2 and C5 can only be the number 1 or the number 7. They are called obvious pairs of numbers in a row. The number 1 and the number 7 can only be in one of the two cells C2 and C5 and cannot be in any other cell. If C2 is the number 1, then C5 is the number 7. Conversely, if C2 is the number 7, then C5 is the number 1. In row C, I consider cell C6. Because the numbers 1 and 7 can only exist in cell C2 and C5, therefore the numbers 1 and 7 cannot exist in cell C6. Continuing to consider cell C6. In the same box as cell C6, the numbers 2, 3, 4, and 5 already exist. In the same column as cell C6, the numbers 8 and 9 already exist. The numbers 1 and 7 can only exist in cell C2 and C5, therefore they cannot exist in cell C6. Conclusion: cell C6 is the number 6. The number 6 has been identified in cell C6. Continuing to use the obvious pair of numbers 1 and 7 in row C. If C2 is 7, then C7 is not the number 7. If C2 is 1, then C5 is 7, and C7 is also not 7. In both cases with C2, the number 7 cannot be in the cell C7. Conclusion: C7 is not the number 7. Consider the top right box. Consider which cell in this box could contain the number 7. C7 is not the number 7 from the conclusion in the previous step. In column 8, the number 7 already exists, so cells A8 and B8 cannot be 7. In this box, the number 7 can only be in one of two cells, A9 or B9. I note the possible cells for the number 7 in this box. Continue to consider row F. Find the possible cell for the number 7 in row F. In the middle right box, the number 7 already exists, so cells F8 and F9 cannot be 7. Consider column 4. The number 7 already exists, so cell F4 cannot be 7. Therefore, in row F, the number 7 can only be in one of two cells, F2 or F5. With the possible cells for the number 7 as above, I proceed to the next step as follows. If F2 is 7, then J2 is not 7 7. If F2 is 7, then J2 is not 7 7. If F2 is not 7, then F5 is 7. If F5 is 7, then C5 cannot be 7. If C5 is not 7, then C2 is 7. If C2 is 7, then J2 cannot be 7 because the two cells are in the same column. In both cases that occur with cell F2, J2 is not 7. Conclusion: J2 is not the number 7. Consider the last row, row J. In the middle box, below, the number 7 already exists, so there is number 7 in cells J4, J5, and J6. In column 8, the number 7 already exists, so cell J8 is not 7. In column 9, the number 7 only exists in cell A9 or B9, so the number 7 cannot exist in cell J9. And J2 is not the number 7 as proven in the previous step. Conclusion: in row J, the number 7 is in box J7. Thank you for watching. Don't forget to like and subscribe.